This is lesson 23, recursive rules. Our warm-up is to graph the arithmetic sequence, and they're giving us the equation a of n equals 2n minus 4. So what we're going to do is we're just going to substitute in our values of n. So I want a of negative 2 is going to equal 2 times negative 2 minus 4. 2 times negative 2 makes negative 4. Negative 4 minus negative 4 makes negative 8. So my first point is negative 2, negative 8. Our next point, we're going to substitute in a negative 1. A of negative 1 equals 2 times negative 1 minus 4, and 2 times negative 1 is negative 2. Negative 2 minus 4 is negative 6. So that's the point negative 1, negative 6. Our next point is a of 0. 2 times 0 minus 4. 2 times 0 is 0. 0 minus 4 is negative 4. And so 0, negative 4 is our point. And now we ought to be able to see that if I move from negative 8 to negative 6, I'm adding 2. And if we go from negative 6 to negative 4, we're adding 2. So we've got a common difference in this sequence of 2. It is not a coincidence that our equation has the 2 right there. So we can say, well, negative 4 plus 2 is going to make negative 2. That would be the point 1, negative 2. You can still see on our graph we're going up 2 for every one that we go over. For every input change, we're going up 2. So negative 2 up 2 would be to 0, 2, 0. 3 would be 2, 3, 2. 4 would be 4, 4, 4. 5 would be 6, 5, 6, and you can see what happens. We get a straight line. Homework questions, we'll do a different time. Today we're going over recursive rules for sequences. So far we've worked the explicit rule, and today we're going to work on the recursive rule. So here's what we want to know. We already should know this first explicit rule. This is what we've been working on for the last 3 days. This explicit rule takes us, the power of the explicit rule takes us straight to a point. That's like what we just had. When we distribute this, our common difference through, and then we add whatever number we get out here when we distribute our common difference from our first number or to our first number, we get something that says like a of n equals, 3n minus 4 or something like that. And that means that from one point to the other point we go up 3. Our common difference is 3. That's what that 3n means. And so what we can do is we can use this explicit rule to go directly to a point or to a term. So if we wanted the fifth term, we'd say a of 5 is 3 times 5 minus 4. So 3 times, and I just made that up. So 3 times 5 is 15 minus 4. So the fifth term would be 11 in this case that I just made up. So today we want to learn about the general recursive rule for arithmetic sequences. And so what a recursive rule does is it relates where we are to where we're from. And so here's a recursive rule. If I said the numbers 3, 6, 9, 12, and then left a space, you guys would all say, well, 3, 6, 9, 12, what? 15. And in your head, that what you did was you said from 3 to 6 we added 3, and 6 to 9 we added 3, and 9 to 15 we added 3, and so what do we need to do to get to our next term? We add 3. And that's exactly what this rule says. This rule says that we have a sub n equals a sub n minus 1, and this means our previous term. So how did we get to 15? Well, this is our nth term, and so our nth term is going to be our previous term. That's a sub n minus 1, n minus 1. This one would be n minus 2. We're on term n. We want to go to we want to find out what that is. So it's our previous term, and then what's it say over here? Plus d, so plus our common difference. What was our common difference? Common difference was 3. 12 plus 3 makes 15. So if we think of it as a sub n minus 1 is our previous term. This is a d here, common difference. So we can write the first terms of a sequence. We're given our first term, and then here's our recursive rule. So what we're going to do is we're going to say, well, the first terms of my sequence, I've got term 1, which is 1. And term 2, this says that this term 2 is going to be my previous term plus 3 is all that means. So what was my previous term? Well, it was a 1. So what's 1 plus 3? That's what this means here, my previous term plus 3. So my second term is 4. So to find our third term, we do the same thing. We take our previous term and we add 3 to it. So 4 plus 3 is 7. We could do the fourth term, take our previous term, which is 7, and add 3 to it. That makes 10. Our fifth term, take our previous term, which is 10, and add 3 to it, and we get 13. So that's a linear, we've got a common difference here. 1, 4, 7, 10, 13. We're going up by the same amount each time. Here's something that's not linear. We don't have a common difference, but it's still a recursive rule because a sub n minus 1 means our previous term. So what they give us here is they say, okay, our 0 term is 1. So the next term that we'd want would be our first term. And how I read this equation here is I read it as the term we're on is going to be the term before plus 2 times the term that we're on, and meaning the number of the term that we're on here for this n. This n is this number. So for example, we'd go here, a sub n minus 1, our previous term, which was a 1, so 1 plus 2 times our n, which in this case it's our first term, so it's 2 times 1. So we say 1 and 2 times 1 is 2, so 1 plus 2 makes 3. So our first term is a 3. To find our second term, we do the same thing. It means our previous term. So our previous term was 3 plus 2 times, and in this case we're going to plug in this 2 here because we're on our second term. 2 times 2 is 4 plus 3 makes 7. And you can already see that this isn't linear because we don't have a common difference, or it's not arithmetic. So because from 1 to get to 3 we have to add 2, and 3 to get to 7 we have to add 4. Let's see what happens on the next one. I bet that it might double each time. So our third term would be 7 plus 2 times we're on our third term, and why we're saying that is because this says n here, and so 7 and 6 make 13. So where we had a change of 2, we had a change of 4, we had a change of 6, so we're going up by 2, plus the term we're on. Okay, you guys try, just do the first one. So take a second here. This says that our first term is 10. So to find the next terms, right here, a sub n minus 1 means, this part means our previous term, and then what are we going to do to our previous term? We're going to subtract 2. So our previous term was 10, 10 minus 2 is 8. Our third term, well, previous term minus 2. 8 minus 2 is 6. Fourth term minus 2, 4. Fifth term minus 2, 2. Writing a recursive rule. So our general form for our recursive rule is a sub n equals a sub n minus 1 plus our common difference. So what do we need to know here? All we need to know is our common difference here. So this is going to be a sub n equals a sub n minus 1 minus 3. You guys can do this. This is going to, our a sub n equals a sub n minus 1 plus our common difference. We'll use that for both of them. So all we care about for 5 is that this d is 4. So a sub n equals a sub n minus 1, our previous term. How do we get to our next term? We add 4 to our previous term. How do we get to our next term? We subtract 2 to our previous term. Writing a recursive rule given a sequence. So here, from 2 to get to 6, I add 4. From 6 to get to 4, I add 4. From 10 to get to 14, I add 4. 14 to get to 8. So pretty soon we can tell, hey, our common difference is 4. Once I have that common difference, now it's exactly like my other equation. A sub n minus 1 plus d, and all we're doing is saying what's our common difference. Common difference is 4. And there's our recursive rule. You guys try this one. What are we adding? 11 and 23, we'd have to add 12. 23 and 35, add 12. Add 12, our common difference is 12. So we'd say a sub n equals a sub n minus 1, our previous term. The term we're on is going to equal the previous term plus 12. That easy. Tonight our homework is 23.